Sorry for the dog video that was shown earlier. Hi, I'm Sean, and these are my group members Sengjie and Daryl. So today we'll be doing a 10-11 Sem 1 examination paper regarding Arrhenius equation. Now let's take a look at the question itself. Question 16a. Explain how Arrhenius' law can be used to explain the temperature effect on the rate of reaction of an irreversible reaction. Now let's move on to the answers for part A. For a reaction to occur, molecules must have a certain amount of energy. This energy is called an activation energy. When temperature is increased, molecules heat up and gain kinetic energy. As a result, more and more molecules have enough energy to overcome the activation energy. This results in higher successful collisions between molecules and thus increase the reaction rate. This can also be said for the opposite. When temperature decreases, kinetic energy decreases. Thus, less and less molecules have enough energy to overcome that of the activation energy. This results in less reaction occurring. Now let's move on to question B. Other than temperature effect, list and explain another two factors that can affect the rate of reaction of an irreversible homogeneous liquid reaction. One way to affect the rate of reaction is by adding a catalyst. By adding a catalyst, it provides an alternative pathway for a reaction to take place, where it lowers the activation energy of the molecule. With a lower activation energy, more molecules will be able to react, and therefore this increases the rate of reaction. Don't worry if you didn't catch what I said. I'll use a diagram to further elaborate on that. This is a Maxwell-Boltzmann distribution curve. It shows on the y-axis the number of molecules against the x-axis the kinetic energy of the molecule. You can see on the left, it shows the molecules without the catalyst, and on the right with a catalyst. Due to the distribution of the energy between the molecules, most molecules do not have enough energy to overcome the activation energy required for a reaction. This can be seen in the graph on your left. However, with an addition of catalysts, the activation energy is shifted to the left, which is seen on the graph at your right. Now, molecules do not need as much energy to overcome that of the activation energy. Therefore, more reactions can occur. A catalyst inhibitor can also be added. This way, the activation energy will be seen to have moved to the right, and therefore more energy will be required by the molecule to react, results in a lower rate of reaction. Another way to increase the rate of reaction is by increasing the concentration of the reactant itself. An increase of concentration, the molecules of the reactants are more abundant. This increases the rate of reaction as more collisions will occur. To put it in a simple analogy, the more monkeys you place together in an enclosure, the more babies you will produce, if you know what I mean. Jokes aside, let's move on to the last and final question. Part C. For the data given in the table below, determine the Arrhenius parameters using a suitable graph method. The first step is to write down the Arrhenius equation. After writing the Arrhenius equation, we have to manipulate the equation into y equals mx plus c. This way, we can plot a graph using the new equation. So how can we get y equals mx plus c? It's fairly simple. We just have to ln the entire equation to get rid of the exponential factor. This way, we will get ln k equals to ln k naught plus negative EA over RT. However, we still have to manipulate it a bit into getting our y equals mx plus c, where our y is our ln k, our ln k naught is our c, our negative EA over r is our gradient, and 1 over t is our x. However, before plotting the graph, we have to convert our values given in the table above into our desired values of ln k and 1 over t. After the data was tabulated Excel was used to plot the graph. As we can see from the graph, this gave us a linear line with an equation of y equals negative 13689 x plus 42.031. Now let's sub the equation back into non-k equals to negative EA over Rx plus non-k naught. Negative EA over R is equals to negative 13689. To get the value of the activation energy, we have to multiply negative 13689 to the gas constant 8.314. This would give us a value of negative 113,810.346. Since there's a negative sign in front of the activation energy, we have to bring it over, and this will give us a value of 113,810.346 joules per mole, which is our activation energy. After finding our activation energy, we can now proceed to find our K0, the frequency factor. Ln K0 is equals to 42.031. So to find K0, we just have to find the exponential of 42.031, which should give us 1.794 times 10 to the power of 18 liters per mole per minute. Finally, we are done with this question. Thank you for watching this video. We hope that you have learned something from it.